Hi, everyone. Welcome to episode 5 of our Hoot series, where we are learning more about service meshes. My name is Graham. I am an engineer here at Solo. And just quick background on myself. I have been working on our new Service Mesh Hub offering, which is not released yet, but will be coming soon. So I've been doing a lot of thinking recently about different service mesh implementations and the trade-offs between one versus the other. So I'm really excited to have the opportunity to share this information. So today we're going to be talking about two service meshes. The first one we're going to talk about is Maish from Containus, and the second one we're going to get to is Kuma from Kong. So I'm gonna real quick get to the docs site for Maish, and we can kind of walk through that together. So let me get to start sharing my screen. And of course, network problem startup right as we start the presentation. But yeah, so to kind of start talking in general terms while we wait for the internet to figure itself out. There we go. So Maish fills kind of an interesting niche in the service mesh hub, in the service mesh landscape. So when you think about different implementations of a mesh and different approaches people may take, you may have some meshes that are more heavyweight to set up, maybe more complex, and they do a ton of different things. And then on the opposite end of that spectrum, you have meshes that are much more lightweight, a lot easier to operate, and they do that at the trade-off of like maybe they do less things. Maybe they're not quite as feature rich. So Maish falls in that second category, the lighter weight one. So it's built. So the data plane for Maish is built on Containus's traffic proxy, and they have really opted for maybe not quite as many features as you might see in, for example, Istio or one of these other meshes. And the trade-off is that Maish is really dead simple to operate. So some of the feature trade-offs, one example that we can point to really quickly is that within your mesh, within your Maish service mesh, there's no MTLS, mutual TLS supported between one service to another. And eliminating the complexity of cert management and rotation and all those security concerns means that there's less for the mesh operator to worry about. So so what else about Maish? So the project was really designed from day one to be Kubernetes native. So there's a lot of really nice native support for different Kubernetes concepts, and the implementation was with Kubernetes in mind. The other nice thing that Maish brings to the table is, as contrasted with some other mesh implementations, Maish really allows you to adopt it through kind of an opt-in approach. So while you're running the mesh, you can continue having your service-to-service communication happen over the normal cluster DNS. So the normal name.namespace.cluster.local DNS approach, but you can really easily change your domain names to service.namespace.maish, and just through that one change, you're now talking through the traffic proxies in the mesh, and you get the nice features. So if you have some services that are ready to use the mesh and others are not, you can kind of piecemeal move to a mesh implementation for your infrastructure. The other kind of interesting defining characteristic for Maish is, like some of the other meshes that we've talked about in this series, the kind of conventional approach is to have a proxy sidecar per pod, and where Maish differs is that, and this diagram is a really nice look at that. That rather than have a proxy per pod, you actually have a proxy per node in your cluster. And all the pods on that one node will share the proxy on that node. And that is nice. You may like that for a couple of reasons. One is, if you don't like the model of your pod YAML getting injected with the sidecar definition, because this doesn't live on the pod, none of your YAML gets updated in any kind of magical way. The proxy is just entirely separate. Another advantage that you might see as you adopt this is, if you are conscious about the compute costs that a proxy per pod is going to introduce, you may potentially save on a lot of computing costs by just having one proxy per node, because you don't need to have the same thing replicated per pod. It's also less invasive in terms of, because the proxy is not in the same pod, you don't need to do any IP table injection, or you don't need to hijack the pod networking like another proxy per pod approach would need to do. So I talked earlier about the configuration of Maish and how it's really fairly simple. The configuration of the mesh by default is actually entirely done through annotations on your already existing services. So for example, to add a service to your mesh, all you need to do is tell Maish that the service communicates over, in this case, the HTTP protocol. And so if you don't want to, there are no custom resource definitions that you need to set up to run the mesh. That being said, if you would like a little more control over things and you're fine with the custom resource definitions being registered in your cluster, Maish also recognizes SMI resources, so service mesh interface resources. Switching it to that mode, that's on an install level, so it can't quite switch easily between the two. But if you're already comfortable with SMI, or you have done some research and think that that might be the future of the way that service meshes are configured, you can run Maish in SMI mode. So yeah, some reasons that you as a mesh operator may adopt Maish. Like why would I use Maish? So some reasons I've kind of landed on with it is, if you are a mesh operator who's doing a lot of really greenfield work, you're doing cloud native work, and you're starting right on Kubernetes. Because Maish is implemented to work on Kubernetes, that will be a pretty seamless addition to your infrastructure. You may also prefer Maish if maybe your mesh operator team is really small, maybe it's just one person, or generally you have seen, or you've evaluated some of the heavier weight meshes like Istio, and you've decided that maybe I really don't need all those features and the complexity of operating the thing. Maish can be a really simple alternative to that. So with that kind of high-level introduction to the characteristics of Maish, I thought we would walk through a brief demo of getting just a bare bones example up and running. So let me switch my screen share here. One moment. Cool. So what I'm running in this window is a GKE environment that I have stood up separately. And we can see that we have the Maish control plane installed to this namespace. So also just a note, K just aliased to kubectl, so nothing crazy there. But if we take a look in that namespace, we see a few things that are interesting to note. So there are a couple observability features that are installed. Not going to talk too much about that as for the purpose of this demo, but suffice to say that through Maish, you can take advantage of the observability features that come with the traffic proxy, but we won't be getting too much into that today. So what's deployed here is the mesh controller pod, this being the entity that serves up configuration to the 3 proxy pods, these Maish mesh pods, and we'll get back to those in a second. The other thing is that Maish depends on core DNS. This cluster I'm running doesn't have core DNS installed, but it was really easy to, they provided a deployment of core DNS and handle integrating that with the default kube DNS that's running this cluster. So just a note about why that is there. But yeah, so if we can really examine that these 3 proxies are actually running on the nodes in the cluster. So we see this cluster is running these 3 nodes with these 3 names. And if we take a look at the YAML definition of the proxy pods, so a little bit of a copy paste here, but what this is doing is getting the proxy pods by this label that Maish attaches to the proxies. And then we're taking a look at the node name on each of the pods and we run that. What we see is that each proxy is actually sitting on one of the nodes that we saw up above. Cool. So let's see. So now we're going to run a little bit of a demo. So what we have here is just like a really dead simple example being created. So in this Kuma namespace, excuse me, we have a client pod that we're just going to SSH into to do some networking. And then we have a server that echoes back information about itself over HTTP. And then another server that just echoes bytes back over TCP. Cool. So if we SSH into the client pod, we can see that we can do the normal Kubernetes networking, over the base, the native DNS. So this is all as we would expect it to be. And then similarly, we can go over the cluster network to send bytes and get bytes back from this other server that we're running. So even though we're running, as we saw, we're running our 3 proxy pods, nothing is actually registered in the cluster yet. So in order to do that, like we saw in the documentation briefly a moment ago, all we need to do is tell Maish what protocol the service should be communicating over. So if we come to our HTTP server and go ahead and add this annotation to it, so just telling it that the traffic type should be HTTP, and then go ahead and save that. That is all it takes. And now the service should be registered. So jumping back into the client, we can see that networking to the service is the same as before in terms of, we can still use the DNS name from before. But if we now change the domain name to .maish, that's going to get intercepted and routed through the corresponding proxy on our node. So if we run that, we see that we actually have these forwarded for these X forwarded headers that say that, yes, we have actually gone through the mesh. And we can do the same thing with the TCP server that is similarly as easy. We come in here and indicate that this one should be communicating over TCP. And we get back into the client, and we should be able to run these netcat commands over whoami-tcp.whoami.mesh. So if we do that, and just like before, this is now being sent through the mesh proxy. So now that we have this, we've seen that we have really easily registered these two services as a part of the mesh. So now we're going to take advantage of one of the one of the features that the mesh offers us, which is doing some really simple rate limiting on these services that are now in the mesh. So if we come in here, there are, let me switch my share back to the Maish docs real quick. So, right. So here we see that they can express a bunch of different things over service annotation. Among them are retries, and these retries as well as rate limiting, and this fundamentally will just get piped down to the traffic proxy, but really simple to set rate limiting on a per service basis with these annotations. So if we do something like that, let me switch back now. Cool. So this is the HTTP service, and fairly arbitrarily, just to get the demo working, we're going to set the rate limiting config to something really small that we can trip easily. So let's set them both to 10 and see what happens. So this is average of requests per second, and this obviously is like bursts of requests over a smaller time window. So we go ahead and save that. And one thing that's interesting to take a look at this point is we can, the details of what I'm typing over here are a little bit not super interesting, but basically I'm forwarding to attempting to port forward to the sorry. Oh yeah, right. So we're going to take a look at the debug API that the Maish controller pod exposes as a part of the debugging tools that they offer. So if we curl to 9000 on localhost, which again has just been port forwarded to the Maish controller, and we get so this endpoint is going to give us the configuration that currently is being served to the proxies in the mesh. So we come in here, there's a few interesting things we can see. So we have explicitly some hosts defined, and this should look familiar. This is what we were curling before. But there's also now this middleware section that is the rate limit config that we have set up. And we can see that our HTTP service does reference that middleware. And so this should be applied to traffic going to that service. Cool. So if we get back into the client pod now, and what we're going to do is just in a really tight loop, we're going to keep curling the service that has been rate limited. And so we expect some requests to go through because not everything will break the rate limit, but we do expect that the offending traffic should get rate limited with a 429. So go ahead and run that, and a lot of output there. But if we see like that some of it is getting through, some of it has not been rate limited, and maybe I need to make the rate limit a little bit tighter, but we should be seeing, yeah. So yeah, we see that some of the traffic has been hit with or has been responded to with a 429 too many requests. So yeah, that's just a demonstration that it took 10 minutes to add the service to the mesh and get rate limiting configured on it. So pretty low barrier to entry on that. Yeah, so I figured I'd pause for a brief moment, maybe questions or anything else before we transition over to talking about the Kuma service mesh. And while we do that, I'm just going to switch over to the other demo cluster that I have set up. Cool. So yeah, Kuma is we talked earlier about the kind of spectrum of mesh implementations in terms of being lighter weight, maybe simpler to operate, and then on the other end, maybe more full featured, a little more complicated. As compared to Maish, Kuma falls a little bit more on the heavier weight, slightly more feature rich side of things. So some important details here about Kuma. Kuma is built on the Envoy proxy, which, as I think we've talked about in the past, is becoming kind of a standard for mesh implementations. The other interesting niche that Kuma sits in the field is that there is support from day one on Kuma for controlling workloads that not only are running on Kubernetes, but may also be running on a virtual machine or bare metal even. So if you maybe have a very heterogeneous infrastructure, or maybe you're in the middle of porting something over to Kubernetes, this mesh may be a good approach for you because you can incorporate lots of things, not just your Kubernetes workloads. The other nice thing about Kuma is that also from day one, there is support for multi-mesh operations. And the way that Kuma in particular handles that is through multi-tenancy within the same cluster. So you have many different services within the same cluster, but you have labeled them, or in Kuma terminology, you have tagged them with different things like the service name, the mesh name that it belongs to, maybe the region that the service lives in. And this is actually kind of a cool approach because it can enable things like, maybe a failover to a different region, or maybe a blue-green deployment. Some of those things that conventionally are kind of hard to implement may be easy if you have set up your Kuma tags in the right way, because traffic routing and traffic policies are expressed on service tags rather than like explicit names and namespaces and things. So because Kuma is, it has this advantage that it can operate over very heterogeneous workloads, we can see in their documentation that there are two modes that it runs in. One is universal mode, where you may be running on Kubernetes, you may be running on virtual machines, it's a mix. And there's also Kubernetes native mode. So in each of the modes, you have different options for what what storage backend that you use. So you can see here that you can opt to use Postgres to store the Kuma state in. So digging in just a little bit here, Kuma CP is the Kuma control plane binary. And so you can provide it with Postgres credentials for it to use. In Kubernetes mode, though, it's a slightly more conventional in that it uses custom resource definitions on the Kubernetes API server to store its state, rather than an additional external data store. So because Kuma is, as I mentioned, farther along the feature-rich side of that spectrum, there is really easy support for things like mutual TLS, really fine-grained traffic policies. All this stuff is fairly easy to set up. It also allows for really fine-grained control of observability features. And this is especially interesting because if you're running multi-tenant Kuma meshes, you may have different observability requirements for each mesh, and you can really drill down on a per mesh basis to configure that. Yeah, so starting to dig a little bit into what you get when you install Kuma. So what I'm doing in the terminal now is I'm going to port forward to on port 5683, and so that by default is the control panel or dashboard or whatever you want to call it that the Kuma ships with by default. So if we fire that up, we can see, just note here in the corner that if you had many different meshes running, we could see them all here. By default, when it starts up, it places everything in a mesh named default. So that's why that is named the way it is. And yeah, we can get a really nice overview of what all is running in this cluster. So I already have a demo that they have put together running here. And we can see on this page that we can drill down into what tags are associated with a particular service, when the last connect time was. Another terminology explanation, the Kuma refers to the Envoy proxies as data planes because they may not be sidecars if you're running outside of Kubernetes. So you would have an entry here per Envoy proxy instance that's running. And we can drill down even farther. We can see that Kuma publishes data plane insights, and on Kubernetes that's just represented as another CRD, but here in this view they have kind of combined everything. So we have the networking config on that particular Envoy instance, and then if we scroll down, we can also see that they publish stats from the Envoy instance itself around whether or not it's in sync with the configuration being served to it. Maybe these are all in sync, and so there's not a field here, but we might see responses unacknowledged, and that would indicate a problem. Maybe the config is invalid, and an application developer writing a service that participates in the mesh may not care about these details, but for engineers at the mesh operator level, this can be a really invaluable debugging tool. So nice to see that they have surfaced that in a really visible way. We can also see on the left that when we eventually would set up other resources, that they would appear here, and similarly we could drill down into them and get a nice view of the state of the cluster as it's running currently. Yeah, so before we jump into actually running the demo, kind of a summary of Kuma as a whole. Maybe again, why would I use this service mesh? I could see this being the right choice if you are maybe a large enterprise that hasn't fully completed the transition to Kubernetes. You've got some virtual machines, you've got some bare metal, it's a mix of stuff. You can use Kuma to manage all of that while you gradually, piece by piece, port your infrastructure over to Kubernetes. You may also find value in it if the multi-tenant, multi-mesh approach is valuable to you. More and more people are starting to adopt that and find value in that. And this can be a nice way to kind of, in a centralized way, manage all of that. And then this UI is really nice. And so if a nice dashboard view is important to you, this has an offering there. A kind of broad comparison can be made to a mesh that I know we've talked about in the past, Consul Connect, which is similar in that it's not restricted to only Kubernetes. You can run it on different workload types. So just as a point of comparison. So again, going to switch my screen share to the terminal now. So cool, we're gonna kill that port forward, and let's take a look at what gets deployed when you actually install Kuma. So I'm running it in Kubernetes mode right now for simplicity. So there will be differences if you're running it in the universal mode. But what we see here is that there is a Kuma control plane component, and that is going to be what ultimately serves as, if you're familiar with Envoy, this is going to be the Envoy XDS server. It's going to be what is serving up config to the Envoy instances. And then the other component that gets installed is the pod that actually handles injecting the sidecar definitions into your pod YAML as they get created. And if we poke around a little more, we can see that there is a CRD instance of that default mesh that we saw earlier. And if we take a look at it, there's no config right now. There is a reference to the MTLS config, but it's not actually currently enabled. So right now, nothing's happening with that. Cool. So I also have here a demo running that the Kuma folks have put together to kind of walk through piece by piece. The Kuma demo app pod is just an Nginx instance forwarding onto the backend. The backend is a Node.js app that fetches, I believe it's, so what's running here is a mocked out online store with things you can put in a cart, etc. So the items are stored in Redis, and the item reviews are coming from Elasticsearch here. So if we actually get that running, we can port forward to the entry point to the app. Cool. So we see here a bunch of items that are for sale, prices, descriptions coming from Redis, and we can click into read reviews, and this is going to be served from Elasticsearch. So yeah, because we haven't set up any policies or anything, this is all happening over plain text in the app. And if we actually now go to, this is, right, so this is a really comprehensive demo that they've put together, and what I've based this portion on. I'm not going to go through all the details, but we can see, so we saw previously that we had traffic working over plain text, and now let's say that we want to enable MTLS in our mesh. So we can see it's pretty much the same as what we saw before, but we're now just flipping the enabled flag to true. And to get into a little more detail, this is just going to use, Kuma is going to auto-generate a root CA that's going to distribute to the proxy instances. You could provide your own cert if you wanted, but this is just using a built-in cert generation functionality. So if we come here and we actually apply, sorry. Cool. So we have configured our mesh. If we take a look now, just to confirm, MTLS has been flipped to true. And if we restart the port forward to that demo application, right, so everything is failing because MTLS is enabled, but we have not actually allowed traffic to go through. So nothing is authorized to talk to anyone else. So now we can get back to the behavior we had before, but still talking over mutual TLS by setting up a traffic permission that basically just says that everything is allowed to talk to everything. And again here, these are not labels in the Kubernetes sense that we're operating on. These are tags that live on the data plane instance. So if we, so for example, this is a service tag that we're matching against, not a label. So if we come here, and I'm just going to copy this into the cluster real quick. So now we have the traffic permission defined. We come back to the app. We should, oh, and if I restart the port forward, it's an important step. Cool. So now everything is back. Communication between the backend and the two different storage backends is working, and everything is happening over TLS. And we could keep going with this. They have a nice logging example that I think is a little too involved for right here, but you know, we can do fine-grained control of our networking. So let's now delete that really permissive traffic permission that we set up, because we see that there are these fake reviews coming in, and we want to stop recording those. So what we're saying here is we're setting up these two traffic permissions. One that the front end, the Nginx instance, is allowed to talk to the back end, and the other that the back end is allowed to talk to Elasticsearch. But note that we have left out Redis from this topology, and so that actually that communication will fail. So if I copy this into the cluster and remember to restart the port forward, we should see that the page loads, and hopefully our review service will be shut off. Yeah, so this is spinning because that request in the backend is failing. So yeah, just a nice demonstration that we have really easily installed the mesh and gotten our services registered, and we were able to use the Kuma traffic policy API to perform some fine-grained control over what traffic is allowed to happen in our application. So yeah, I think that is a reasonable stopping point-ish for the Kuma demo. So I think I will pause again and wait for any questions about Kuma or about Maish or anything. Additionally, if there are questions that you think of after the live broadcast, if you're watching it, you know, later recorded, feel free to jump into our solo.io public Slack and ask questions there. We'd be happy to help in that context as well.